space solar power and seeing how it might be financed with our sort of game show in the guise of Shark Tank called our Orca Bowl. And we are going to have our lovely orcas here take and evaluate Martin Soltau's and then John Mankin's respective pitches. For the purposes of the game, Martin's is going to be an earlier phase project, and John's is taking place a few years later after ground stage development has happened in order to demonstrate the breadth of what the project may entail for financing. And with that, I am going to take and give an opportunity for each of the orcas to introduce first themselves and then the roles they're playing today. So, if you would kindly start, Peter.
All right, so in real life, I was a full career Department of Defense employee where I have pushed space solar power for about a decade and a half. And then I retired to join a think tank that, in fact, just yesterday came out with a pro space solar power paper. And my role here is that, and I should also say a long time in tech. I actually encountered space solar power when I was the Chief of Future Technology for Headquarters Air Force. And so here I am playing a Department of Energy representative that has a remit to spend some money on a diversity of projects for renewable energy, and comes with all the nationalist concerns that a U.S. department would have about trying to onshore capability and protect intellectual property, as well as a perhaps comparatively I am looking to make the most of the public dollar by leveraging investment with private capital.
Good morning. I'm Alan Thompson. In real life, I'm responsible for government affairs in a small launch vehicle manufacturer from Scotland. And my background before that, I worked in international development and finance for a couple of development institutions. And that's the reason why this morning, I think, my role is to represent a sovereign wealth fund whose challenges are not just the standard commercial challenges, but expressing an interest in this initiative, trying to recreate, as I said, not just the commercial return, but the sustainable development goals return. What does development finance look for in a project such as this? How does it make a difference? What's the game changer? What's this concept of blended finance? Why do we think that blended finance could be a solution to help us unlock a whole amount of development money to go into space infrastructure investments? These kind of challenges. Yes, I suppose the idea here is that the Sovereign Wealth Fund is not quite a limitless source of financing, but it's these kind of different dynamics that I will hope to recreate in my questioning this morning. Thank you.
Good morning. My name is Agnieszka Łukaszczyk. In the real life, I'm a Vice President for Government Affairs for Europe, Middle East, and Africa at Planet. Before that, I was working at the European Commission on the Copernicus program, so we were working with, we're looking also at companies and startups and trying to help them to enter the market. Here, for the purposes of this session, I'm a regional government representative for a region in West Germany. I want to bring investment, talent, innovation to my region. I got some money to spend, so impress me.
Good morning. I'm Jim Caravalla, CEO of Offworld. As a prospective billionaire, I am building machine intelligent swarming industrial robots for operating industrial processes on Earth, Moon, Mars, and the asteroids. As an orca, I'm an actual billionaire building machine intelligent robots for building industrial processes on the Earth, Moon, Mars, and asteroids with a moon base and a few other activities in space. Forbes rates my net worth at about $100 billion. I think it's grossly underestimated. My access to the asteroids with our robotic swarm architecture affords me a net worth of at least $250 billion with a reality dysfunction of 99%. That makes me a trillionaire. Thank you.
I don't know how to follow this. So I'm Raphael in IRL. In real life, I'm a space-focused venture capitalist. I have a seed stage space venture firm called E2MC Ventures, which some of you may know. But like Jim, I'm basically playing myself. So here I'm also a space venture. Well, I'm actually a deep tech venture capitalist. The fund size here is slightly bigger than my actual fund size, so that's nice. And I'm very interested in space-based solar power. I am here investing at the seed stage as well. So I need a pretty attractive return profile, at least 30 to 50x. And because I come in so early, I'm of course, and I don't have as much money as the other guys, I'm very worried about getting diluted to shreds. So I will be looking for some de-risking factors to mitigate that. And I also will try to convince Jim that he should just philanthropically donate money rather than invest.
Good morning, Orcas. My name is Martin Solto. I'm the co-CEO of Space Solar Limited, and I'd like to introduce you to an opportunity for a unique and transformational investment in the development and commercialization of space-based solar power. Next slide, please. So, next slide, please. This thing? Okay, thank you. So space-based solar power is going to be a transformational clean energy technology. Decarbonisation and security of energy supply and avoiding energy poverty are three absolutely central and pressing priorities for nations globally. And we cannot get to net zero with our current energy technologies. Intermittent renewables will not do it alone. And we need new sources of dispatchable and baseload power to complement our existing technologies. So space solar power is the concept. It's long been considered viable. It's a large satellite in a high Earth orbit where it can see the sun for 100% of the time almost. It harvests solar energy in space, converts that to high-frequency radio waves and beams it down to a fixed receiving antenna on the Earth, where it's converted back into electricity and delivered into the grid at city scale, gigawatt scale power, dispatchable and baseload. And there have been 3 independent studies recently which all confirm the technical feasibility and the economic viability of space-based solar power, and moreover, it will bring huge economic benefit to investors and nations. Uniquely, it offers a collection of characteristics, really beneficial characteristics. Not only that baseload and dispatchable characteristic, which is so important for the stability of the grid with intermittent renewables, but it's scalable, it's safe, it's secure, it has a very low environmental impact, and it's affordable. And crucially, finally, and uniquely, it is exportable. You can steer the beam to deliver power to other nations with cooperating systems. And so it's like a very flexible interconnector, but without any of the fixed cable infrastructure. So there's a number of factors for success. And Space Solar Limited has the exclusive IP in the market-leading solar power satellite design. It's called Cassiopeia. I won't go into the details technically, but the benefits are, because of its architecture, it has a very low levelized cost of electricity, a low mass, high specific power, and therefore it is not only very affordable and attractive to the market, it also has great operational utility, and it'll help us to get to the commercial power quicker because it opens up the possibility of a very investable development route. One of its characteristics as a sun-pointing satellite architecture is that it can use highly elliptical orbits, and this provides great utility in 2 ways. Firstly, it's a lot cheaper in space lift to put it into an elliptical orbit rather than geosynchronous, just the energy. And secondly, it can access a unique range of different markets in polar orbits, so strong utility for Latin America, Middle East, Asia, and also Northern Europe and polar regions. So really, really important market and operational characteristics. This shows the levelized cost of electricity in dollars per megawatt hour. Space solar power up the top there, very competitive with the less capable intermittent renewables, about a third of the cost of our current baseload clean energy technologies. And this, combined with it's going to be very attractive to the market, given it's so capable. And a development program generate about 180 billion euros of economic benefit from the development. So it's clearly an ambitious program with many challenges across political, economic, societal, technical, legal, and environmental aspects. But none of these are insurmountable. If we think beyond business as usual, if we bring together public and private finance, if we build those important international partnerships, and if we have long-term vision, all this is deliverable. So we have developed a roadmap to address those areas of risk. There's a mobilization phase and then 4 main development phases, totaling $13.5 billion. Phase 1 is to de-risk the core technologies, including wireless power beaming and the in-orbit robotic assembly. Phase 2, at the end of year 6, will see a demonstration in low Earth orbit of delivering megawatt scale power from space. And at that point, the UK government has said it would put space-based solar power into energy policy, into the net zero pathways. And that will be a tipping point when we expect the energy sector will come in and invest. We'll be able to use debt finance to fund the rest of the development program. Before then, we expect it's more equity. At the end of year 9, phase 3 is developing the commercial scale power at 100 megawatt scale, and that's going to provide some utility commercial returns into niche markets, perhaps those remote regions. And then finally, after year 12, we've got industrial scale, a first of a kind system delivering gigawatt scale power, city scale, with all of the manufacturing processes and supply chain industrialized and mature, and building out the production and program from there on. The market is huge for renewable energy baseload. In 2050, the demand will be about 50 billion megawatt hours of clean electricity, and we confidently predict that space-based solar power can take 20% of that. That's the addressable market. And so that's $1 trillion market for space-based solar power. And of course, there are these early opportunities along that roadmap and the later stages of the roadmap for these niche applications in areas where they might command higher prices for those earlier products. So Space Solar Limited has a number of differentiators and make it a truly unique investment proposition for you Yorkers. We have the IP in the market-leading solar power satellite. We have created the environment in the UK, a supportive policy and political environment, which is absolutely key for success. It's clearly going to be an international venture, but it needs to have a government-led initiative with a supportive host nation. We have strong media presence and very positive coverage. We have an established supply chain. We've established the Space Energy Initiative, which is a collaboration of over 65 organizations. They're international, but they've got a UK footprint, and that delivers us a fantastically capable supply chain. And then we've got a highly investable roadmap and a very commercial approach, which is going to deliver this in the most rapid and agile way. So, AUKUS, I'm seeking partners to join us on this journey to transform our energy future. And I have pledges already of $190 million towards phase one. I'm looking for $100 million from you for an equity stake in Space Solar of 20%. And this is your opportunity to be a founding investor in this transformative technology, which will really shape the next industrial revolution. So, Peter, this is your opportunity to get to net zero in a sustainable way, and it will complement your other investments in renewable technology. Jim, you can be a founding investor in this extraordinary transformation, and it will also help deliver the capable in-space robotics, which are going to be absolutely transformational capability for the next economic revolution in space. Aniska, we firmly believe that this will help you deliver energy security for Northern Europe, and it will also generate huge economic growth and many jobs in high-value, high-technology sector. Rafael, this will deliver for your clients the ultimate ESG investment with many off-ramps for your funds. And Alan, this offers you, again, the opportunity for Norway to be a leading player in a transformative clean energy technology, and I ask for your support through the whole journey. Thank you very much.
Thank you. And now you have 8 minutes for the negotiation phase, so good luck.
Thanks, Martin, for the great presentation. Tell me, what are the customer contracts you have in place right now?
So we're at the start of the journey here, Jim. We've got, as I say, two investors who have pledged a substantial amount. The UK government has put in £6 million at the moment for an initial investment in some of the early tech. So that's a really strong pledge of investment from a major government.
Yeah, sorry, go ahead. No, I was wondering, so obviously I'm the VC and I'm coming in very early stage. You seem to imply a $400 million pre-money valuation, which, forgive me, I'm quite unclear how you justify that, because you don't seem to really have a lot of, I mean, this is a very exciting project, but there isn't really anything there yet, right? This is all in the future.
I would suggest the pre-money valuation is actually pretty substantial, and it comprises three things. So it's the IP in a highly capable concept, and I wouldn't, this is absolutely central to a successful space-based solar power program. There are many initiatives globally which don't have those compelling concepts, and that's one thing. Secondly, we've got this policy and political support from the UK government, and again, that's an absolutely essential key. And thirdly, we've got this environment with the Space Energy Initiative, with a developed supply chain. So I think Space Solar Limited has substantial value from those three components.
Would you consider manufacturing somewhere other than the UK?
Absolutely. So there's probably three ways for investors to get revenue. One is licensing, technology, manufacturing. It absolutely needs international partners globally, and so yes, we very much hope to see others manufacturing our licensed technology.
For the first phase that you're looking for, what's the geo return? Do you have some kind of notion of not just manufacturing, but what kind of economic development that you mentioned? What are we looking at? How many jobs are you creating? Where are those jobs going to be created? How are they going to be created? What about the skills gap? Who's going to be making the equipment? How are you going about that?
Yes.
And I suppose the final question from my side for the moment is, if you've got the UK involved, What are they putting on the table?
Okay, so in terms of the return in jobs, the independent study for the UK estimated that this would generate 143,000 job years across the programme. In terms of where those jobs are, they're in...
That's phase one, or that's the...
That's the 12-year programme, yeah. So in terms of the sectors, it's very much digital, manufacturing, space systems, energy systems, cyber and security. They're all sort of high-value, important sectors and disciplines. It's going to bring in new industries and new space, and particularly in the kind of high-volume manufacturing sector as well. And then, what are the UK putting in? Well, they're putting in 6 million initially. That's already pledged, and we have some really positive conversations about future support as well. But I think this is where AUKUS, it needs to be a public and private partnership. The governments need to see you investing, and so that they can have confidence as well. And it's the same the other way around.
What exactly are the deliverables at the end of phase one?
So there'll be multiple demonstrations in space, but particularly demonstrating some of the key technologies around in-orbit robotic assembly, and proving out some of the power beaming technology. So there'll be very visible outputs from the end of phase one. I put up that risk slide with those 6 areas, and what we aim to do is to retire many of those risks. So this is not just about technical development, it's about making sure that we answer all of the questions in all of those areas. And particularly on the sort of societal front, we need to socialise this with the public and get broad support. We're developing a transformational and disruptive new energy technology, and getting strong societal and political support is going to be key.
But just to be clear, because of course you're competing against a diversity of other projects, at least in my department, that will be delivering green power to the grid in this same time frame. My understanding is that you're going to do some robotic demos, but there's no actual green energy going into the grid that the Department of Energy would be able to trumpet as actually contributing within phase one to the climate change problem. Is that right?
Well, phase one is just 3 years. So if we take the timescale between now and 2050, we'll be delivering green energy into the grid within 9 years intermittently, and baseload within 12 years.
I'll be retired by then.
But this is where we need long-term vision, Peter. You can set the direction of travel, and this is where we absolutely need those long-term investors.
Okay, here's my pitch, back to you. All right, Martin, this is excellent. Here's what I propose. I'll put in 50 million for 10% on 4 conditions. I want a 50 million option for the remaining 10% of this round if you don't fill it. A seat on the board. My team have just formed another company now in the last 6 minutes, which will want exclusive power contracts for negotiations globally, and I want exclusive manufacturing and assembling rights in space for the network for my robotics company.
Thank you, Jim. I think we need to think more globally about exclusive manufacturing rights, but I would accept your offer of 50 million for 10% and with the option. But we need to be able to license this globally. We've got to build these systems to, and in terms of the capacity and pace, we can't constrain that. But if that's possible,
So let's talk.
Where is your new company incorporated?
The new company is incorporated in Luxembourg.
So on those terms, unfortunately, I think our fund will not be able to participate, but I do want to help you. So I wonder whether there is component technologies of part of the stack that you have to invent or develop anywhere, which we could independently finance as earlier stage ventures and help you in that way.
Okay, thank you. Rafael.
I suppose a similar question, or continuing on from the same thing. Either you eat the gorilla whole by parts, or you split it up and try to do it separately. I suppose I'm interested in the longer term. Obviously, 15, 20 years, maybe after the time you've passed on, but hey. We're interested in energy security. We're interested in jobs. We're interested in growth. How are you planning to go about managing the geopolitical dissonance, particularly around things such as energy and what you expect to arise when you're providing such a low-cost version of energy to the Earth going forward?
So this is not competing with other renewable energy technologies. It's making the whole system work as a whole, and it'll be different in different nations. Some nations have nuclear, others elect not to do that. So it's really important. The only thing this is competing with is.
Yeah.
What's your pitch, Alan?
All right, so I don't mind making up the remaining 50 million, but I want you to reincorporate in the United States, and I want the narrative to be about U.S. leadership for energy security globally, and I want all launches of the system to come from the United States.
Thank
I-
you, Peter. That's
Yeah, I think you're going to have some choices to make here. Obviously, I have to bring some jobs to Germany. We are developing launchers as well. So in my interest would be to incorporate in Germany and launch from Europe. So you're going to have to make some choices. Obviously, it's probably not going to happen that all of us will be able to invest, but think about it. We have some other pitches to hear from. So good luck, and let us know where your priorities are.
yeah. Thank you, Agnieszka.
So we're a larger market with cheaper launches,
No,
but there will be jobs to build rectennas and subcomponents. I'm sure that there could be an accommodation.
And think of all the power plugs the rest of the world can make.
Exactly. And I think we need to be fairly agnostic to launch because, again, capacity, we cannot be constrained to a single launch provider. We've got to develop this and scale it up as quickly as possible.
Buddy, seize the moment. Hustle, hustle.
There's no way that you're going to get the Department of Energy to be funding potential adversarial competitors to launch or have their hands on the core IP. So it's one thing to have it within the NATO community,
Yeah.
but the moment that you start bridging your finance out, the United States and DOE is out.
Okay, so that's it. 50-50, we're done, we're in. Good.
Well, I think I've got my 100 million. I think I can negotiate with Peter to persuade him that we, with natural partners, we can get the other. And Jim's going to give us the 100 million if Peter can't. Thank you.
Thank you, Martin, for presenting that. We're running on a bit of a clock here, so I'm going to quickly introduce our next pitch for John. As I said before, this pitch is happening a few years later after that development phase so that we can see what financing looks like in a later stage. All of our investors here don't have any conflicts on their budget from the first to the second round, so everything is a clean slate. John, please take the stage.
Good evening, Orcas. Thank you so much for waiting through the long commercial break we just heard. I'd like to speak to you about an opportunity to invest, to make billions, and to build a better future for billions. The SPS Alpha option. Next, please. Wait, I got this. So, as you know, there are huge challenges with energy. What Mencken Space Technology, a California-based firm in the U.S., is seeking is an investment of $300 million in exchange for a 30% stake in the firm. We are working in partnership with Solar Space Technologies, based in Melbourne, Australia, to develop, deploy, and demonstrate the first SPS Alpha hypermodular space solar power system in low Earth orbit within 4 years, and to achieve gigawatt-class space solar power for global delivery within 10 years. The SPS Alpha satellite involves an arbitrarily large phased array and can make a significant contribution to carbon net zero. And we believe that it can become the primary or preeminent power source for both government and commercial space operations, the resource-focused space operations on lunar and cislunar space in the coming 5 years. So the opportunity, obviously, as you know well, tremendous risks of greenhouse gas-driven climate change, trillions of dollars are engaged, and hundreds of millions of lives are going to be impacted one way or the other in the coming years. Dramatic increases in investment in carbon net zero energy, focusing on existing technology, ground solar, wind, energy storage, nuclear, less and less on hydro as the changes in the weather make hydro an unreliable option, and as locations have already, the best hydro locations have already been utilized, and the need to soon transition beyond gas turbine and combined cycle gas turbine, which have been so prevalent during the last 20 years. The search for novel last mile solutions, new technology solutions, is heating up. The wind does not always blow and the sun does not always shine, at least on Earth. The sun does not always shine, and there is a tremendous opportunity for new solutions if they can be brought to market in a timely way. One such option, and the one that we are developing, is SPS Alpha. It is the most practical, lowest risk space solar power design option on the market today. It involves highly modular and mass-produced hardware. It takes advantage of the advances in low-cost launch that have come in the last 5 years, uses autonomous assembly via robotic systems that are based on the platform, takes advantage of high-efficiency solid-state electronics, uses microwave wireless power transmission in the 2 to 10 gigahertz range, and because of its modular architecture, for which Mankin Space and Solar Space Technologies own the critical IP on the standards and interfaces, we can evolve module by module, either solar or electronics or wireless power or robotics, all within our system of standards and interfaces. What we have done so far, we have developed during the last 24 months the first light, as you will, first generation versions of all the major modules. We have tested these in a new facility, which we developed working with the Government of Victoria, the Australia Centre for Energy and Space, with an initial investment of about $50 million Australian, through government grants and selected early investors. So far, we have achieved an initial demonstration of 2 kilometers and 50 kilowatts of power transmission using, on the ground, modules that are of the same character and with the same interfaces, as I described, as those that will be used in space. We have engaged international partners and vendors, not just within the US and Australia, but also internationally, particularly in the UK, in Europe, and in Japan. In the longer term future, where we are going is to the vision of space solar power for wide ranges of the world, and with not just baseload energy, but dispatchable baseload energy, so that a deployed solar power satellite can switch between delivering power to Berlin to delivering power to Kinshasa based on the load demand essentially on a minute-by-minute basis. The ground receivers that we're developing can be deployed either onshore, offshore, or in agricultural areas. They are elevated some 10 meters above the ground and are 80% transparent. They involve only a 20% fill factor, and so rain and sunlight, fresh air will pass through the ground receivers without fundamentally disrupting the utilization of that land. Our numbers, just a quick run through. The cost summary, 2 gigawatt delivery on the ground, has a platform mass of about 7,600 tons. Our nominal lifetime is 40 years, but in point of fact, our economic numbers are based on 3% per year operations and maintenance cost. 3% of the platform is replaced in our analysis every year, so the platform is essentially immortal. We've just chosen a 40-year cutoff for purposes of the economic and other analyses. We've assumed a cost of financing on the order of 5% per year in perpetuity, 3% per year cost for operation and maintenance. Our end-to-end efficiency is 20%. Our availability is 99.9%. The deployment cost, because of the very low cost of launch that has emerged independently, is on order 5 billion, ground receiver on the order of 300 million, and our targeted levelized cost of electricity about 5 cents per kilowatt hour, which, along with our dispatchability, we believe will make us an extremely attractive option for deployment worldwide. In terms of the business case, looking at a particular scenario with a deployment of 10 platforms, delivering power to 30 ground receivers, and a 40-year period, we end up with on order net sales from each platform on order $2 billion per year, and net revenues on order, after all expenses, on order $1 billion per year. Over the lifetime of the platform, we're anticipating revenues on the order of $60 billion per solar power satellite, primarily due to the 24/7 operations. Since the sun shines almost continuously in space, we generate money almost continuously in space. And we have the opportunity, with a wholesale price of electricity of about $150 per megawatt hour, and you can see, if you care to discuss them, the cost breakdown for how we come up with that number. We come up with the $60 billion net present value for the revenue stream per satellite. Our energy return on energy investment approaches 100 to 1, and that is based strictly on the presumption of the 40-year lifetime. Our energy payback is on the order of 60 days, as opposed to conventional terrestrial solar, where energy paybacks can be on the order of a couple of years, depending on the location on Earth where the solar is deployed. What we are proposing now is to develop the next generation of modules for the various elements of the system, to launch and deploy an SPS alpha demonstration in low Earth orbit, generating 300 kilowatts, and our time to launch is planned to be 48 months from the date of availability of funds. As I said, we are seeking $300 million. We are offering a 30% stake, and our near-term market for this system is cislunar space. If you look at the power requirements that are emerging from several dozen countries for the moon, for power in Earth orbit and in near-Earth space, it approaches hundreds of kilowatts. At this time, there is no good solution for how that power will be delivered affordably and in a timely fashion. We believe that solar-powered modules of the SPS alpha type can enable the development of lunar resources and be a turnkey option within the next 5 years of revenues in that marketplace which is now emerging. Thank you for your kind attention. We look forward to working with you going forward.
Yeah, thank you, John. Those numbers, again, are so big, they scare me so much that I will leave. Actually, I have a train to catch in real life. But a question for you. What can you do to de-risk this further? So de-risking it for my limited partners, but also for the public taxpayers. And this could be things like maybe a lower capital need than 300 million is possible, maybe a smaller scale demonstrator. I really like the fact that you talked about alternative use cases like beaming power to the moon. Maybe you can elaborate a little bit how much revenue that could generate in what time frame. And that also should, I guess, provide the potential for public grants, I don't know, from NASA, from DoD or other entities involved, and whether you have any idea yet what kind of, what part of the financing could come from non-dilutive sources.
So a lot of question in a short but sentence with a lot of semicolons. So let me try to address it. I think the challenge of space solar power is certainly a component level challenge, and so there can always be flight experiments and flight demos of individual components to help to de-risk. But honestly, I believe that at the end of the day, it's a systems level, all up demonstration a la how SpaceX developed the Falcon 9 reusable and how the Starship and Heavy booster were developed that will turn the corner on making space solar power a financial reality. So I certainly agree there could be other de-risking efforts of that sort, but I believe that an all-up systems level demo approach to systems engineering and development, as was followed by SpaceX, is the right approach here. And that's why we're seeking this level of funding at this time. We're doing our de-risking in the ground facility, which is a full-up facility, the largest anechoic chamber in Australia, which one that also opens up the doors and allows us to do power transmission over several kilometers in an airfield near Geelong. And so we think that we've got a good combination of ground facility for ground test and taking it to systems level on orbit. As an example, there's an established parameter within the Global Exploration Roadmap of the International Space Exploration Coordination Group, seeking, it's several years old now, but seeking 300 kilowatts of power on the moon. And that power, if provided by conventional systems or by space nuclear reactor power systems, would approach, $2, $3, $4, $5 billion in terms of CapEx. We believe we can do the same job for the same market for on the order of $100 to $200 million. And that somewhere in between, again, following in the footsteps of SpaceX, following behind that, we will offer for sale on the moon power for dollars per kilowatt hour when we're generating it for fractions of a dollar per kilowatt hour as compared to conventional, for example, space nuclear power systems, which run on the order of $50 to $100 per kilowatt hour. And that's our market advantage.
A quick one, John. Thank you for the excellent presentation. If your initial market is lunar, Are you planning to use lasers for the power transmission or microwave
Yeah.
as you would for Earth expansion?
So, and we believe that there's an opportunity for both technologies, but with regard to the use of laser power transmission, it's really more targeted on low power applications, i.e. On the order of 100 watts to several hundred watts, to mobile systems, i.e. to a particular roving robotic vehicle. In our case, what we're looking to is to not to the study of lunar resources, not to science probes going down into a crater like the Viper or some other system. We're looking to hundreds of robots developing lunar resources in a system architecture analogous to terrestrial mining, where those are EVs that recharge. And so we're looking to an architecture where you have point-to-point over about 20 to 30 kilometers from the illuminated ridge lines down into the permanently shadowed canyons with fixed endpoints. And as a consequence, what you want is an alternative, a substitute to a traditional power line, which is quite awkward and expensive on the moon, and just you do it with a wireless power transmission point-to-point link, in which case efficiency is all important. And because the efficiency of the microwave system we anticipate will be higher, that's our approach. But we don't see laser as being a bad thing to send power to a rover. But if you want to operate a mine, like terrestrial mines, there's going to be hundreds of electrical vehicles and literally
So it scales to higher.
thousands of tons a year of mining.
Thank you.
Can you tell me who are your main competitors?
So with regard to the lunar and cislunar applications, our main competitors are the more conventional solar arrays, where it's on a mast. Somebody puts up a solar array, and they generate power for the immediate vicinity. Those immediate systems, those systems are running on the order of $10 to $20 per kilowatt hour, and they only go where the cable can reach. When you run out of extension cord, you stop, but that's a major competitor. Another is the same kind of system, but with small modular nuclear reactor systems. And as mentioned, they have the finite reach, and moreover, they are also on the order of $50 to $100 per kilowatt hour in terms of cost. But they are more conservative. They are more better understood. For terrestrial markets, there really are only a couple of options in the market that are competitors for us. One of them, of course, is the well-known Cassiopeia system, which was developed to a certain point by the United Kingdom several years ago before they adopted the SPS Alpha standards. And there is, of course, the ongoing R&D that was going on in Japan and in China. China, in particular, is a very different architecture. It's an integrated or monolithic architecture. They've been having some trouble with the high voltage power management and distribution, and at the moment we think we're several years ahead of them.
Thank you.
Thank you, very interesting. I'd like to ask about, I can see the economics, I can see the jobs delivered, I can see the development point of view. What I'm missing here is the environmental impact. And what I'm missing here is, so specifically for the time of the project that you're looking at, what are we talking about in terms of CO2 emissions that go into manufacturing on the ground? What are we talking about, in terms of the ultimate environmental impact in every single environment in which you're planning to undertake this work? Because apart from the geo return, apart from the jobs, I understood that the main motivation for this project is actually to save the environment. So you said something about touching 100 million lives of people on Earth and giving them cheaper energy, which will help achieve net zero. How is it going to achieve net zero? What is it that you're focused on in your activities that will help me understand as an investor to achieve an environmental return?
Right. So the space solar power architecture, SPS Alpha, by its nature has an extremely small carbon footprint as a system. It has approximately the same amount of CO2 inputs as a ground-based solar array, roughly, plus the carbon cost of the launch. However, it generates power 24/7, 99.9% of the year, as opposed to terrestrial solar, which has a far less energy effective life cycle during the course of a year. So our estimates are that our carbon footprint is on the order of 1% of natural gas and is similarly less than ground-based solar. But what we're anticipating is that space-based solar's greatest impact will come from its dispatchability. One of the huge barriers, the reason I described it as the last mile problem, one of the huge barriers for conventional renewables is that they are intermittent in character. And their primary alternative is steady state in character, i.e. nuclear. Once you start up a nuclear reactor power system, it just runs. Whether you use the electricity or you don't use the electricity, you don't cool off the reactor core. It's just burning. So they match, one of them, the nuclear reactor system can be a very good foundation for baseload, but it's not especially tunable to the day-night cycle, to the diurnal cycle of load in the power grid. What space solar power can do, what SPS Alpha can do, is it can serve at 4 in the afternoon or between 4 and 7, it can serve Berlin. And then you can switch the power to another location that needs it overnight, maybe running a carbon capture and sequestration station somewhere in the savannah. And then in the morning, you can put it down in London where it's overcast and rainy, and there is no sun to convert, and then switch it again in the afternoon to another marketplace. So we see it as enabling a much more extensive deployment of terrestrial renewables by offsetting the need for excessive amounts of overcapacity and energy storage.
John, what I don't see is the clarity of the growth strategy. So you outline. So you outline this stage, and then you sort of showcase the total project of the 10, right? So what I'm unclear about is, at the end of this, how close are you to immediately building your first actual SPS Alpha that's delivering 2 gigawatts, and what is the level of investment that has to happen at that point to move forward?
So our architecture planning involves moving from this initial low Earth orbit demonstration to a MEO, a middle Earth orbit pilot plant. And by going to MEO, we believe that we can achieve a substantial reduction in the required size of the system compared to being in geostationary Earth orbit, and still deliver in a pilot plant tens of megawatts to terrestrial receivers. And so that MEO system, which is at a distance of, it doesn't really matter the details, let me just say, the size of the MEO system is about 10% the size of the GEO-system, and the cost is about $1.5 billion, allowing for margin. So the next stage...
Do you have any customers, letters of interest for that system?
We, in fact, have 3 letters of interest from different mining companies. We believe we can deliver tens of megawatts initially.
Any
growing,
in the U.S.?
Because of the architecture, they are in South America, they are in the sub-Saharan Africa, they are in Australia, they're in some specific locations in the South Pacific. None of them happen to be in the U.S.
Strategic minerals? Of interest to the US?
Absolutely strategic minerals, especially in South America and in sub-Saharan Africa.
I have a quick question for you. This is very exciting what you're presenting, and I can see my region benefiting from the solutions, but I do represent public money, so there has to be some sort of return on investment, and I'm just wondering, why should a a region in Germany invest in a company in Australia?
Well, at the moment, the partnership is between the U.S. and Australia. And
So far away from Germany.
I understand. But we have contracts with vendors, with some of the major suppliers in Europe, including in Germany, to provide modules and to provide system integration and to provide the ground stations, which are very substantial investments, and we'd need 3 ground stations for each platform. What we anticipate and what we are working towards with the next stage is to establish a manufacturing capability to the standards that we're establishing almost everywhere in the world. We see this as an opportunity to create an industry, and the development of each solar power satellite will involve on the order of 50,000 jobs. And once you finish the manufacturing and deployment, the 3% per year replenishment involves on the order of 10,000 jobs per year forever for the system. So there are a large number of jobs involved in accomplishing the first development of space solar power and then the ongoing operation and replenishment of the system and its repair and refurbishment. We believe that certainly Germany can have a very substantial role in that if they choose to, and we are absolutely open to that.
Well, this is great. So I think if we could come to an agreement that you would have some substantial manufacturing done in my region, which would create jobs, then we could probably contribute about 80 million to your project.
Fabulous.
I'm also ready to consider probably about a 50 million investment. However, I'm really concerned about this environmental impact assessment. So I would probably put that as a condition, and also a commitment from your company to not just, as governments are doing at the moment, but driving down CO2 emissions. So some kind of metric, some kind of absolute value that you can actually contribute in terms of that environmental impact. Because as far as I'm concerned, we can manage the money's good, we can deliver the power, but we've got the jobs. If we don't do something about the environment now, and actually we need to achieve that net zero, and we need to have companies like you doing a little bit extra in that regard. So I need a commitment from an environmental impact assessment, not just on Earth, but also in the moon. And what the potential side effects could be. I also wanted to come back, there was a point on the microwave transmission. How are you going to manage people's perception that that's safe?
Yeah.
I mean, you could be burning up these polar ice caps with the microwave transmission of the power. What about that? But maybe it will come in the environmental impact assessment.
And we would absolutely commit to that.
Okay.
So unfortunately, I just committed my budget of 50 million investment into our previous proposition. But here's what I can do for you, John. I'll take 100 million from my foundation and donate it for a convertible note equity stake that converts to my company on maturation, on the condition that I can have first rights of refusal of power delivery to lunar operations for your precursor lunar setup. And we can operate on that basis, plus an unlimited supply of Western Australian Cabernet to my facilities.
We can certainly pursue that, but with only one caveat. I of course cannot commit to not providing power to U.S. government mission operations, but commercial operations on the moon, absolutely.
Fair enough.
Jim, you can do better than that. I mean, this is a real scalable opportunity that's ready to take off. And this is highly compatible with your business plans.
Totally.
Now, my concern, I'm willing to throw substantial money at this from the U.S. government, but I need to know that somebody's going to be committed enough with their own dollars to make it scale for the next level, right? You've got that, you've got access to that, but I don't want to see this fall flat after year 3, right? I want to see this actually transition. So I want to hear a better offer from you, and I will close this deal.
For the subsequent round, For the subsequent round, if we meet the metrics of this round one for 300 million, our enterprise will lead a round, will syndicate a round for the entire amount capitalized for the next round. But I will want chairman of the board position, and we will want over 50% controlling stake in the company. But at that point, we will see this thing fly and take off, funded by revenue-generating contracts from power companies around the world.
We don't need visibility or chairmanships. We just want the public good.
So there's a lot to like about this, and it comes at a terrific time in bureaucratic politics. So since the last administration, there's been a change in leadership, and it so happens that the head of the Department of Energy, rather than being deferential to NASA, actually wants to get the scoop on NASA with the administration. And so the idea that we can get the scoop by displaying leadership for the Department of Energy on the National Space Council is outstanding. Like the narrative about Australia, like the ability of you to integrate globally with our European and Quad partners. In fact, we would be open to manufacturing. Want to make sure that you stay it's okay to be a joint venture, but we definitely want you to have a U.S. component. The cost to close the remaining deal is that, like anything that has national security implications, we're going to want to have a seat at the board at the table, and we want to make sure that a condition of your controlling share is that does not devolve or get sold to a U.S. adversary.
Absolutely, agreed.
Can I suggest an escalation to other development banks so that we can take away this kind of adversarial competition between investors? So we actually involve the World Bank, who are now totally on board, as you know, with investing in space infrastructure, so that we actually can focus on a delivery for humankind rather than any specific, while I respect the interests, the geopolitical interests of colleagues, Germany, Australia, and the US, I think there is an element that we need to be able to elevate this to the next level, incorporating interest and yet at the same time trying to take it to a more global humanistic return, which is where I think we need to head.
So let me ask you a question. So I deeply appreciate Jim's offer to make the note, to finish it, but with his earlier offer, which I did not say no to, and the other discussion, we were at a total of $230 million already, with $100 million in a foundation donation at this time. And so I would ask you, can we go to the World Bank and raise that last $70 million at this time?
I'm sure that'd be...
Not to say that we don't want the deal for the next round, but because so far the U.S. government has not offered to actually put in any funding, and we would absolutely be willing to work with the Department of Energy to assure the ongoing leadership of the U.S. in this new field. But if there was an offer of funding from DOE, it would be in the context of the trade with the World Bank.
From my point of view, given the colleagues would accept it, I'd be very happy to be part of a presentation to the World Bank.
DOE is willing to make up the remaining budget to keep it as a U.S. leadership project.
Okay, so in that context, I would basically say yes to that deal and have my orcas all on board with this round, and then pursue aggressively with your help what the next round looks like, because we're going to have to start the organization of the full-scale development immediately and not wait for the launch of this the planned platform in low Earth orbit. So thank you so much.
Thank you, John. I would like to take and give the opportunity here that our orcas, either in their roles or in their actual life roles, to answer some questions and talk about this plan. We'd like to hear from the audience any questions you may have on this project. We're pretty short on time here, so try and keep it brief.
Any question for anybody?
If you have money, that's okay too. Not just questions.
So a little bit more of a technical question, and thank you for showing these amazing roadmaps for a new source of green energy. Yeah, my name is Dorian. I'm from iSpace, and my question is related to the station keeping of the space-based assets. Could you elaborate a little bit on the cost or the challenges of maintaining the position of these assets and how you plan on servicing them through their lifetime?
Yeah, so very quickly, both the Cassiopeia, and I hope Martin didn't mind my little shtick there, but, he transitioned to my standards. Both Cassiopeia and SPS Alpha involve the redirection of sunlight using large reflectors. We are currently planning to use those reflectors to use solar pressure for a large fraction of the station keeping requirement of 50 meters per second per year. So we have that as a strategy. Also, with regard to the SPS Alpha, there are actually planned into the numbers some substantial number of solar electric power and propulsion modules that are used to transport the system from LEO to GEO and then stay with the platform, sort of like 12 firemen holding a basket, holding a net. They stay with the platform to provide station keeping during the life of the operation of their modules. So it's an integrated scenario for station keeping and resupply and maintenance.
First of all, can I thank you? This has been a fascinating set of presentations. I really commend the group who thought this up to put forward this approach, because it really does get to the heart to some of the key issues that I guess you guys are going to start to experience. I wish I had some money sitting in my check bank, but I don't. However, I do worry about one aspect of solar power, and that is the vulnerability of the assets in orbit. And I do wonder whether the venture capitalists, how they might react to the fact that these assets are potentially, you can take them out with fairly conventional means. That may not be a problem, but I do worry about the amount you'll have to invest in protecting the security of your asset in orbit.
Now,
Shall I answer? So we had some really good conversations with the head of space at the Ministry of Defence. And the conclusion is, whilst it clearly needs proper study, was that these systems are no more vulnerable than critical national infrastructure on Earth. It's partly because they're very, very sparse structures and they're hypermodular, as John was explaining. Quite difficult to take out, completely, and you could, and degrade it substantially. And if an adversary wants to take it out, it's an act of war, and quite difficult to do. So, a really important aspect, but actually there weren't any, critical vulnerabilities that were, any worse than terrestrial CNI.
There's so many more actors that can attack an equivalent power plant on Earth than can reach space. Does it have that vulnerability? It does, but it's no more vulnerable than a power plant on Earth, which can be attacked in a much greater variety.
So may I ask a question to the audience? So this is the first time I think that anything like this has been done at an IAC. Systemically, what do you think about it as a format for a structured discussion? It's good? Okay, excellent. So please be sure to give feedback, because I think in future, and I don't mean to be closing the session, I just want to speak to this idea. In future, we could be doing an Orca Bowl on the future of lunar mining, or the future of Mars settlements, or the future of, and pick some other opportunity in the future, and have this same kind of structured conversation at the IAC on that topic, like we've done this time on space solar power. So please give feedback to the leadership of the IAF saying, by golly, this was a good session.
We're so glad that you all came here, and if you have more questions, please feel to contact any of these people. We would love to answer your questions, but in respect of the next session for the Great Planetary Defense Quiz, we need to transition to that event.
And let me just say, three cheers of thanks to the orcas for their efforts, and especially to Eduardo and to Kevin of Lightbridge, who played such an essential behind-the-scenes role in setting the stage for the game, the roles and responsibilities and who's what. And so, thank you.
And thank you all for coming. So, see you.